Alright, in this video we are going to create animation. So let us copy this and try to create another ball. Maybe for this one we're going to give it a blue color. And what's more so, let's maybe make it smaller. And we can even move it somewhere maybe here. Now this is drawn on top of the red one. I'm going to move it somewhere here. Let me save this, show you that this is actually a small ball. And what we can do, what I want to show you is that we can also get hold of the width and height of the canvas itself and use that in our calculation. So let's do const x, and I want to put that in the middle of the width of the canvas. So if this is the width, the half point is going to be like this line right over there. And let's also give it a y. And I'm going to use like the height of the canvas. This is the height of the canvas, right? This is the width and this is the height. And I'm going to use the height and from the bottom of the canvas come up a bit, maybe like 20, 30 pixels. So let's do canvas height minus 30 pixels. And we can go and put X and Y here, save this. And if you look at it now, I've got this, a small square in here. And what I want to do with it is to move it around to create animation. And animation really is frames drawn one after another. And when you see it moving on in a loop, it creates the illusion of movement. So we can, for example, to give this a try, we can go and run this in a loop. So let's say for and let's try something like let I start at 0 and maybe go like as long as I is less than 50 and I plus equal 10. Maybe that's too big, maybe like 5 or something like that. So let's save this. And so I want to add this I to my X and Y, and you can see what happened there, right? This is happening while I want to move it up. So let's like move this on a diagonal. I add to the X, so it's going to move to the right, and let's subtract from the Y, so it's going to come up. So there you go. This is well, we're adding 5 and we're going to 50, so this is about 10 times this rectangle is being printed on the canvas. Now if we want to do this in a way that it appears it sort of, the update to the canvas appears every time the canvas gets refreshed, because what you see here in a canvas, the browser can create an animation effect, or what we call an animation loop, and every time and like show this to you in a way that the differences between the two different frames are not discernible. So that's typically something like 30 frames per second or 60 frames per second based on your hardware and settings. And so if I change the canvas at that rate, you're not going to recognize a sort of a pause in between those changes, and it's going to appear like a smooth movement to you. So there are a few different ways that we can go about doing it. What I will do here is to wrap this in a function. This is one way to do it. Let's call this draw. And what we will do is we use a function on the global window object. This function is called request animation frame. And so what this does is that it tells the browser to call a callback function, and I'm going to give this draw back to it. So I'll explain to you what I'm doing. We have to also call draw maybe the first time so that we kick it in action. And then every time draw is called, it tells the browser that before the next screen is being printed, call draw again. And then again, this happens, and again, this happens. So every time the browser is going to like show you a new frame, this draw function is being called. And this way it sort of creates a like an infinite kind of a infinite mutual recursion here. Like this function calls draw calls this function, and this square will basically get animated by like moving. So like I don't have the I variable anymore. Let me create that. Let's actually make this a bit more idiomatic in terms of how people typically work with this. So let's change this to let, so we can then update x and y. So let's say x is plus equal, let's define like a delta x, a dx for delta x, and let's make it even like a smaller movement so it's more smooth. Const dy, and put that as 2 as well. And so let's say add a delta x to x and subtract a delta y to y. You can also like say add to both of them and then put the minus in here. The minus or plus here just helps us to decide on the direction, right? So delta x, if the delta is a positive value, then it moves to the right, and if it's a negative value, it's going to move to the left. And same as story with the delta y, if it's positive, it's going to go down, if it's negative, it's going to go up. So if the x coordinate moves towards right and the y coordinates moves up, then the whole thing is going to move sort of diagonally to the top right corner. Okay, and so what we're doing is we're basically drawing something, right? And then we update the xy coordinate of it and we draw it again and again and again and again, and this keeps going to happen. So there you go. You see, let me refresh this one more time for you to see it better, right? And this is not quite exactly what we want because it looks like it leaves a trail. If you want that square to feel as if it's moving, you shouldn't keep drawing it on top of the previous canvas. You need to like clear the canvas and draw it in a new place. So basically every frame should show just this rectangle in its new position. And when you move those frames quickly one after another, it gives you the illusion of movement. And so that's not a difficult thing to do. We can go and say ctx, and we can use this clear rectangle function. And here we basically say, like, you can like specify a part of the canvas and ask this to clear it up. If you specify the entire canvas, so you start at like the top left, and then you say get the whole width and height of the canvas, then every time this function is called, it basically cleans the canvas, so whatever was like drawn on it previously is not going to appear again, and then it draws something new to it. So let's save this, and now you see, let me refresh that again. You see the ball is moving to the top right. By the way, notice that the red square is gone, and the reason for it is that well, it sort of this happens, like it draws the red square, right? But then immediately when you come here and you call the draw function, you clear it up. And this happens so fast that it is not discernible to us. Our eyes are not going to be able to detect it when this happens as fast as like 30 times per second. So it's like 1/30th of a second that red square is there, and the next moment it's not there anymore, and it happens so fast that we don't even recognize it. So when I refresh this, even though that drawing happened, I don't really see it. So let's pay a bit more attention, because we are sort of setting up the scene for the work that's going to come later our way. Anything that I want to draw here and I want to animate here, it's basically is going to happen inside this draw function, right? And if I'm careful about what I'm creating at every frame, I may be able to create the illusion of something is being animated and is moving around. Okay, so this is a good stage for us to pause, and then we're gonna go to the next recording and start building up our game infrastructure.